Welcome to This Explainer. Today, we're going to completely rebuild your mental model of quality work. Because, let's be honest, if you've been paying any attention to the software world lately, you've definitely felt the ground shifting beneath your feet. It feels like every single week there's a new flood of AI testing tools hitting the market, and the noise is just incredibly overwhelming. AI is literally everywhere, and software quality assurance, or SQA, is right in the crosshairs. But we're not here today to just rattle off another top 10 list of tools. No, instead, we're taking it back to first principles. We're going to build a really wholesome, deep understanding of exactly how AI fits into SQA, why it actually works, where it completely falls apart, and how you can master this massive paradigm shift. So, let's just address the elephant in the room right off the bat. Will AI replace quality assurance? The short answer? No. But the longer, way more fascinating answer is that while AI doesn't replace human judgment, it radically changes its scale and its speed. Think about a really busy workshop where highly skilled people are inspecting complex, finished items entirely by eye. They're incredibly fast, right? But eventually, humans get exhausted. We're physically limited by how much we can notice, remember, and repeat day in and day out before our eyes just glaze over. AI doesn't erase the need for that core quality work. Instead, it takes over the tireless, infinite scale of repetition, which completely changes the shape of how we work. Section 1. The ceiling of manual QA. Now, we need to notice the fundamental difference between our own minds and the systems we build. Traditional QA is hitting a physical ceiling right now because it's essentially just human effort pitted against rapidly growing, hyper-complex software systems. The human domain is absolutely brilliant because we can improvise around fuzzy ambiguity. Think about how easily you can read between the lines of a terribly written Jira ticket and just intuitively know what the developer actually meant. But the machine domain? It strictly needs stable patterns to handle repetition. And this is the first irreducible truth of automation. You simply cannot automate what you cannot define well enough. Think about making a cup of tea. If you ask a machine, hey, what tea fits my rainy day mood and slightly tired appetite today, you're going to completely break its brain. That's a fuzzy human domain problem. It's just not stable enough for strict automation. But a washing machine, you don't ask it how the fabric feels emotionally. You give it a strict, highly repeatable process. Automation simply trades human attention for machine repetition. It frees up your exhausted attention so you can finally focus on actual, nuanced human judgment. Section 2. AI's promise and peril. Adding AI to the mix is where things get truly interesting. Because AI isn't magic, you guys. It's simply a very high-speed pattern generator. And the absolute golden rule here is this. Automation verifies pattern, humans interpret consequence. Think of a smoke detector. A smoke detector is fantastic at noticing a sudden change in the environment. It detects the signal, but it has absolutely no idea if that smoke is coming from slightly burnt toast or a raging fire in your kitchen. Only a human knows the actual consequence of that smoke. The AI detects the delta, you interpret the impact. So where does this high-speed pattern generator actually shine? Well, AI is brilliant at reducing and organizing massive amounts of information wherever stable patterns exist. Imagine taking 10,000 lines of incredibly noisy logs from a chaotic Friday night server crash and summarizing them in literally seconds to find the one crucial warning. It's incredible at generating a massive list of edge case test ideas from a messy user story, or clustering hundreds of similar defects together, or spotting likely risky areas right after a massive code change. It's kind of like having a tireless assistant who can read a mountain of mixed documents in a heartbeat and tell you exactly where the most important stuff is. But we have to talk about the danger zone because we need to be deeply aware of AI's perils. AI models are dangerously fluent, and they frequently disguise that fluency as absolute truth. I mean, they can write a perfectly clean, grammatically flawless explanation of a completely terrible test idea. They also completely miss in visual business context. For instance, the AI has no clue that a checkout button behaves weirdly because of some strange legacy code decision your team made 3 years ago just to satisfy a key client. It misses all those unwritten rules. And honestly, worst of all is shallow correctness. That's when the AI is technically right but for the wrong reasons, meaning it's going to completely break the moment the product changes even slightly. And this brings us to a really critical point, understanding the fundamental difference between correctness and reliability. Correctness just means the AI's output is right this one time, like it made a lucky guess on a single run. Reliability, on the other hand, means the output stays dependable across repeated use, through complex edge cases and evolving software changes. We absolutely have to treat AI output as a probabilistic proposal, not a guaranteed verdict. It's giving you the mathematically most likely answer based on historical patterns, not the absolute truth. If we want true reliability, we're going to have to build it ourselves. Section 3. Framing AI for reliability. Because as we just saw, reliability doesn't just happen automatically. It has to be deliberately designed. And we do this through something called human framing. This is the essential mechanism you need to turn a random AI helper into a controlled, powerful accelerator. When AI gives you a suggestion, you should instantly sort it into one of these trust buckets. If a task is strongly structured, like, say, parsing standard log files, you can give it higher trust. If it's context-sensitive, like guessing regression risk, well, that's medium trust because it requires deep product knowledge. And if it's ambiguous or interpretive, like deciding if a user will actually feel frustrated by a new layout, that requires lower trust. Why? Because human emotion and nuance are completely alien to an algorithm. The closer a task gets to human meaning, the more careful framing and scrutiny it requires from you. To actually put this into practice, you need to use what we call the trust ladder. It's a really concrete 4-step process. Step 1, the AI suggests something. Step 2, a human reviews it for fit. Step 3, the team validates it against actual product reality. And step 4, only then does it influence action. Listen, if you skip step 2 or 3, your quality system becomes dangerously fragile. Bypassing human validation is literally like handing the steering wheel of a speeding car over to a system that fundamentally doesn't understand what a wall is. But if you faithfully follow this ladder, you ensure AI suggestions are safely anchored to reality before you make a move. Section 4. Becoming a quality strategist. Mastering everything we've talked about today doesn't just change your daily tool set. It actually forces a professional evolution in how you approach your entire career and the very questions you ask about your work. Mature teams with this new mindset, they stop asking basic questions like, hey, can we use AI here? Instead, they start asking deep, strategic questions. What is the specific failure mode if the AI gets this wrong? Is this task a repeatable pattern, or is it a nuanced human judgment call? How do we keep the human in the loop without slowing the whole process down? You start strategically placing human scrutiny exactly where it belongs. And that is such an incredibly empowering identity shift. You're no longer just moving from being a manual tester to being an AI tool user. You're evolving from a tester into a quality strategist. You aren't just learning how to prompt a chatbot, you're mastering how quality systems think. You're learning to see exactly where AI adds massive leverage and where quality still, absolutely unequivocally, depends on human accountability. So I'll leave you with this final, critical thought to chew on. Are you ready to define the boundaries of your AI? Because remember, in this new paradigm, humans set the boundary, and AI simply explores the space inside it. It's your judgment, your context, and your specific framing that makes this technology reliable. Thank you so much for joining me for this explainer. Now I want you to go look at your own quality systems and ask yourself, where will you draw the line?